Good afternoon. I've been able to stay awake through the post-lunch sleepies, not only through the good talks, but through the anticipation that I get to echo Stephen and provide a little bit of a sampling of the library's response, and in this case, really focusing on some of the infrastructure and services that have been developed at Stanford as we look at digital library services in the age of data and open access. And if you look at a high level, what does a library do is it provides information to the scholars of today and to tomorrow. If you try to define that inductively, it might look something like this list of activities. So it selects resources to add to collections, it acquires them, catalogs them so they can be to enable discovery, holds them until such point as they might actually need to be accessed by scholars, provides circulation, whether physical or digital, and then it preserves those for the next generation of scholars. And if you look at models of the research of the information lifecycle, you'll see something conceptually that goes from conceiving a research project or a research question through planning and proposing, collecting data, refining and analyzing it, and then publishing it. And then libraries provide that critical or a key part in that critical activity of the return or closing the loop. And I think what we're seeing now as data begins to enter the picture and it becomes part of the scholarly communication process is that there's some elaboration on this, which is in a kind of a classical example as part of the refine and analyze step or possibly part of the publication step. There's a data deposit event, some management activities, ongoing preservation services, and then dissemination of data. And we might see publication of data or published articles actually citing data and vice versa. And that if you then close the loop, you get this virtuous circle with data actually being reused and being able to stand on the shoulder of previous researchers. And so the Stanford Digital Repository is Stanford's long-running response to meet some of the needs around data preservation, especially for the have-nots, especially for what is often called the long tail of science, which is particularly in data curation for all of the excellent discipline and domain-specific repositories out there. There is a long tail, and actually if we had clickers, I'd like to get a sense of how many people think that they're in the long tail versus well taken care of by some of the existing systems of data and domain-specific resources that really don't have a good, well-identified, community-supported home. So the SDR, the Stanford Digital Repository, is actually, it's a core library service. It's something that the university librarian started up actually at the turn of the century, at least conceptually. It's been in production since 2006. It is Stanford's large-scale digital preservation system for the enterprise. It's also a platform for asset management and delivery, as it's becoming increasingly difficult to disentangle preservation from the management of information or access to it. And currently, there are about 125 terabytes of unique data, which comprises 250,000 roughly objects and 100 million files. And it's got all manner of content, books, manuscripts, articles, theses, images, media, data. And when we think about digital preservation services, digital asset management services, we really divide the world up into kind of three spheres. So it's the management of content, which includes the ability to deposit it, either individually or in bulk, the ability to describe it, something that librarians are ascribed the great pleasure in doing that, but in fact there are not enough resources, and in fact no one else seems to share that love. The ability to license, to embargo, control access, and then also the ability critically to version information over time. And then specifically within our framework and also our architecture, we actually have two separate spheres. One is a large-scale data preservation environment where we ingest content, we perform auditing and fixity services on it, we replicate that data, we store it for the long term, we migrate it to new media, new formats as required, and then perhaps most critically, we retrieve it when asked. There's no point in doing the rest of it unless you can get the data back out. And then in terms of access, we look at searching, browsing, and harvesting, as Stephen mentioned, a critically important form of access. And then a whole series of delivery services and delivery systems, including persistent resolution, rendering applications for different types of files and MIME types, API-based access, and something that we're beginning to hone in on is metrics and reporting for supporting compliance, and also to give different senses of the level of impact and reach of individual data assets. So as we looked at standing up services for the Stanford campus, and as we were looking at really what kind of services do Stanford researchers request and require, the ability to control access was, of course, a critical one. And so, but that's just one leg of the stool. Equally important, and from a librarian standpoint, is unless the content is clearly licensed and unless there's support for time-based access control, or in this case embargo, there's a real barrier to deposit and to wanting to actually put your content into some centrally managed location. Just as importantly is attribution and use statements to be able to actually not only find the data, but be able to appropriately attribute it and provide conditions of individual use is a critical feature of the repository. On the access side, one of the critical features that we offer is persistent URLs, which is every piece of content is given a unique identifier called a DRUID, Digital Resource Unique Identifier, which is a Stanford-specific schema, and then each of those assets are discoverable at an object level by going to perl.stanford.edu and then / the DRUID. And then within that, we'll actually extract the metadata, the file assets, the rights and attribution statements, and display it on one stable Perl page, which as technology changes over time, the identifier and the content won't, but the rendering of the content might, and we expect this page to resolve consistently as the citation source, but the rendering may in fact change. And actually, I did a somewhat hasty transcription of one of Victoria's middle slides because I think it was a great intro to the way we've actually framed the problem, which is for openness in science, you need the infrastructure to facilitate the deposit and the curation of data and code, links to published articles, and permanence of links. And if we look at just 2 case studies, see how we do here. This is an article that was published by a Stanford PhD student who has since graduated, left the university, and is pursuing his research elsewhere on the wide range selection of Pacific salmon conservation. He and a couple of colleagues actually performed research over a number of years, which led to a happy event in terms of a publication. And down in the conservation value, they say that we focused on 1998 to 2005 because this period had the most consistent data as they were analyzing catchment data, and a list of sources and resources available at www.stanford.edu in Malin Pinsky's AFS space. The great thing about AFS space is the university provides it, and it's large and in fact can be expanded while you're here. The unfortunate thing about AFS space is once you leave the university, I think it's 4 months for academic staff, it gets turned off. And the data is persisted for some period of time, but is subject to reduction. So we have a great case where we had a researcher who actually published an article and linked to their data, and then unfortunately the serving of that data didn't persist. In the happy event, then 2012, we actually released the Stanford Digital Repository self-deposit service, and this is one of the first bits of data that we brought in. So we actually deposited the data. We contacted the researcher, who we still had contact with, managed to get description and licensing information. Our excellent science data librarians actually retroactively introduced all of this for Malin, and now we were happily able to interpose ourselves into the proxy system at Stanford. And so instead of getting a 404 page at AFS, we redirected the Stanford Digital Repository. Another case, so this is a screenshot of the actual digital repository where we have a growing number of collections. And here is kind of a driver's side view of what the repository looks like. From the depositors section, where you can enter in, this is a paper by David Donahoe and Hetef Monogemi from the statistics department. You upload various files, abstract keywords, so standard repository things. And one of the nice things from here, we have that separation of the management, access, and preservation. A copy of all of this goes into our preservation environment. A copy also goes into our access environment. SearchWorks, which is a standard library catalog, if I do a search on Donahoe, and that was a title search, so that's not going to work. If I do an author search on Donahoe, I'll see there are 288 items at Stanford which have Donahoe as an author. There are, in fact, 2 computer files. And the second one here is the code and data supplement for the screenshot that we were just looking at. And if I click on that, I'll see a full catalog record along with all of the other publications by David Donahoe in the Stanford Library's holdings. And then we have a full catalog record including the abstract citation, part of a collection, subjects, URIs, and then I can actually go to the persistent URL to be able to retrieve, again, the persistent citation. Two of the things that Victoria mentioned on her callouts were the related publication. So in this case, it's Proceedings of the Natural Academy of Sciences, and that will open up the PNAS journal article. And there is also, one of the other things that Victoria mentioned is an executable supplement to the papers running at runmycode.org, where the data and the code used to generate the data are actually running in a virtualized server environment, and you can go and replicate the content. So again, all of that is linked from the Stanford Digital Repository. And I think this is one of the key things, also we heard it in Dan's talk this morning, is that this is an ecosystem. It is in fact a web. Data and papers are getting more and more complicated. What we're looking to provide is a resource and a safe haven for the data and the resources that don't otherwise a safe home, and interlink with other sites on the internet which provide value-added processing, value-added rendering, or cross-link with other elements or other collaborators. And I think this is the future of how we see repository services developing. And so I wanted to, there we go. In the last few minute, I just wanted to mention one other element that's being developed. This morning you heard about locks and clocks mentioned a couple of times, which is one of the longest standing and most successful digital preservation initiatives in library and the data space. LOCK stands for lots of copies, keeps stuff safe. And it's become a meme at this point. Deepen is looking at taking the LOCKS model and the LOCKS metaphor and really stepping that up to a level of large-scale data replication for library assets, both the published articles as well as the data. And the notion is briefly that as different repositories begin to develop, you see some centralization into larger sets of nodes, each of which may have local preservation environments, which lets the contributing nodes specialize in management and access services while preservation is taken care of somewhere else. The challenge is if a individual preservation node happens to go away, that content is at risk. And so by creating a federation of large-scale preservation environments and doing reciprocal backup and reciprocal exchange, you can build a preservation backbone for the academy, for scholarly resources, both published articles as well as data. And that allows, as data comes in and replicates out to other nodes, if any of the nodes have a failure, it can be restored from one of the remote nodes. If any of the repositories cease to become a going concern, the data can be retrieved completely wholesale and restored to the original. And then I think critically to the Deepen vision is over long periods of time, as nodes enter and leave, as institutions enter and leave this network. In fact, future members of the academic network or the academic environment can retrieve content even if the original producer and consumer of information in the original archives are no longer there. So what happens in 30 years or what happens in 50 years, the network succeeds the livelihood of any of the individual parts of the network. And you can find out more at Deepen at deepen.org. It's being stood up right now by about 60 large research universities with the notion that if working together at scale and working to secure preservation and access rights, we're actually in a position to do something that individually none of the individual institutions or even the smaller preservation arrangements can sustain by themselves. And then lastly, I think because this is great, this is a little bit of what Stanford is doing. You heard what our colleagues across the Bay are doing. From a library perspective, probably listed in order of most solvable to most complicated, the big challenges that we're looking at is technical integration. So in this ecosystem or this web of repository services, what role should we play and how do we complement the systems that are also in the labs, the systems that are at publisher sites, the domain repositories? That's actually the easy stuff. One of the things that bedevils us, and I think is an evolving tapestry, is what's the distribution of curation responsibilities? Who will actually deposit and describe their data? And that might, in fact, be tied up with the funding mechanisms, because it's probably those who are paid to do it may be the ones that end up doing it. And then finally, Stephen also alluded to this, is how do you actually integrate into the existing workflows? So with that, that's a little bit of where Stanford is and some of the open questions about where we may be going.
Thanks, Tom. We have time for one question.
Yeah, thanks for that talk. I enjoyed that and the previous one. This question of curation and things, it reminds me when I have my students graduate, I have this collection of hard disks in my office. You know, I have them put all their data there, and I hope that if we ever want to, or a subsequent student go back to it, we'll find our way through it. And it strikes me that you know, if these systems were more useful to students as they're doing their work, you know, in other words, it's not like I publish it all when I get done. It's like if I get done an experiment, I curate it and everything, and could I load it with a DOI into the library system? As an advisor, I would like that because that's an easy way for me to get hold of it while the student's doing their work. And then I think Stephen's talked before, you know, if you do this stuff as you're collecting the data, it's just a lot easier to have the long-term preservation. And I'm curious how the library take on that, because it would mean you'd be taking in a lot more data, you know, sort of, it'd be published data, but it's not publications in the sense of the archival journals we're used to.
I think that the theory is, because we know how hard it is to do it downstream, is the further you move upstream, the easier it's going to be. An easy example of that is actually just registering stuff at the beginning. So at least you have a common handle as it moves downstream, even if you load the data or the description later on. That has proven to be practical in some cases. I think in others, in this box, in the collect the data box, let's see the mouse there, in the collect the data box, maybe in fact that's where the data is deposited. From a separation of concerns in different environments, I think the challenge just begins, how do you know when to actually migrate the data to further environments? Because in our environment, if we try to spin everything, if we loaded everything up into Amazon, it would be untenable. So at some point, you do have to provide the selection procedures. We would certainly be happy to look at moving data into a managed environment earlier. Our experience has also been that can, depending on the lab and the workflow, that is also equally challenging. That was a long way of saying, yeah, maybe that will work. I don't know. Sorry. Maybe Stephen knows.
Thanks, Tom. We need to bring someone in remotely, so we'll set that up right now. It'll be just a minute.